For section 1.6, I'm going to divide it up into two different days. So for today, we're going to look at midpoint and distance formula, and then tomorrow we're going to look at the Pythagorean theorem. So for midpoint and distance formula, you need to know what a coordinate plane is. And the coordinate plane is a plane that is divided into four regions by a horizontal line, which is called the x-axis, and a vertical line that's called the y-axis. So basically, the coordinate plane is where you plot your points. You guys have used them for years. You know what I'm talking about. So midpoint formula, you need to write this down, is x from your first point plus x from your second point divided by 2. That'll give you your x coordinate of the midpoint. And then for the y coordinate, you're going to take y from your first point, add y from your second point, and divide that by 2. So how do you get those x1 and x2, y1, y2 numbers? You use the endpoints of the segment that they're given you. So over here next to the formula, I wrote the endpoints of segment AB. So you have to use the point from A and the point from B, the xy coordinates. And it's just like when we did slope back in algebra, is your first point are your x1 and y1, and then your second point is your x2 and y2. So we're going to use this formula to find the midpoint, which is the middle, the exact middle of the line. So example 1 wants us to find the coordinates of the midpoint of CD, of segment CD, with endpoints of C and D given. So we are going to, I'm going to call point C our number 1 point, and point D is our number 2 point. So for our x coordinate, we are going to do x1 plus x2. So I'm going to do -2 plus 4, and then I'm going to have to divide that by 2. So -2 plus 4 would give me 2, and then I have 2 at the bottom. So 2 over 2 is 1. So I have the x coordinate of my answer. It is 1. I'm going to write it over off to the side in an ordered pair. So now I have to do the y coordinate, which is y1 plus y2 divided by 2. So y from my first point is -1. I'm going to add y from my second point, which is 2, and I'm going to divide that by 2. So -1 plus 2 would give me 1, and I have 2 at the bottom. So that coordinate is just 1/2. So if I go over to this picture and plot a point at 1/2, it goes right there, and that would be the exact midpoint of that line. So that is my answer. They wanted the ordered pair of that point. For example 2, it says M is the midpoint of segment AB. A has coordinates of 2, 2, and M has a coordinate of 4, -3. We need to find the coordinates of point B. This one we're going to have to kind of work backwards because they're already giving us the midpoint and we have to find one of the coordinates. So if we think about the midpoint formula for the x value, I'm going to have to take x1 plus x2 and divide that by 2. Well, I have A, so that can be my point number 1. So I have the x1 is 2. I don't know what that second value is, so x2, and I know that 2 is at the bottom. I also know when that gets simplified, I'm going to get the x value of my midpoint, which is 4. Okay, so if I filled in the formula with my 2 points, I would get the answer of 4, -3. So now I filled in everything that I knew out of my formula, and I'm going to have to work backwards. So the first thing that I have to undo is this divide by 2. So I'm going to multiply both sides by 2, and that will leave me with 2 plus x2 equals 2 times 4 is 8. And then I'm going to have to minus 2 from both sides. So I'm going to have x sub 2, and 8 minus 2 would be 6. So we're finding the coordinates of point B, and I just figured out that x value should be 6. And I have to do the same thing for the y value. And I know that the y value formula for the midpoint is y1 plus y2 all over 2. And we're going to go ahead and plug in what we know. I know that y from point number 1 is 2. I don't know what the y2 value is, so I'm going to leave that y2. and we have to divide it by 2. And then if I go back and look at the midpoint, it's telling me that the y value is -3. So this is all going to be equal to -3. So same thing here. I'm going to have to work backwards and solve for that y2. So I have to get rid of a divide by 2 first. So I'm going to multiply by 2. So I'm going to have 2 plus y2 equals -6. And then I'm going to have to minus 2 from both sides. -6 minus 2 would give me -8. So the y coordinate of my point B would be -8. Now moving on, we have the distance formula. And the distance formula is the square root of the quantity of x2 minus x1 squared plus the quantity of y2 minus y1 squared. So now we're going to find how long is the segment that they're giving us. And we can't measure them because they're on an angle. So if they were straight up and down or straight across, we could simply just count how many boxes across are they. But since they're on an angle, we can't do that. We have to use this formula. So it's example 3 says find AB and CD and then determine if the segment AB is congruent to segment CD. So in order to figure out if they're congruent, we have to figure out if they're the same length. So AB in the picture, we have to find its ordered pairs. And so I'm going to write segment AB over here so we know which one we're working with. We have 0, 3 for point A. And we have 5, 1 for point B. And then we're going to plug that information into the distance formula, which is the square root of x for my second point. So the second point I wrote was that 5, 1, and x out of there is 5. Minus x for my first point would be 0 squared plus y for my second point would be 1 minus y from my first point would be 3 and square that. So then we have to go through and simplify. 5 minus 0 is 5 and 5 squared is 25. And then 1 minus 3 is -2 and -2 squared would give us 4. So 25 plus 4 is the square root of 29. 9 is not a perfect square, so I'm going to leave it just like that for a minute, and we're going to go and work with segment CD and see if we get the square root of 29 as well. So segment CD, our ordered pair looks like -1, +1, and D is -3, -4. So again, we're going to plug this into our formula. X from my second point would be -3 minus x from my first point would be -1, and we have to square that. And add y from my second point would be -4 minus y from my first point would be 1 and square that. So now we have to go through and simplify. -3 minus a -1 actually turns into +1. So -3 plus 1 would be -2. -2 squared would be 4. And then in the other set of parentheses, we have -4 minus 1 would be -5. And -5 squared would be 25. So +25. And then if I add those together, I get the square root of 29. So it says to determine if segment AB is congruent to segment CD. We just proved that it was. They both had the same distance. So they're the same length. So we can say yes, they are. And our proof is in the work above.